Welcome to Software Design and Modelling Introduction. In this brief video I'm going to try to give you an overview of what this course is about, and I'm going to also say something about what you are supposed and expected to know already. It's fine if there are small gaps that you need to fill in, but I'm going to tell you what you're expected to know already so that you can go and fill in any gaps that you may have. And hopefully I'm telling you this soon enough that if there are enormous gaps, you still have time to choose a different course instead. So here is how I tend to think about the way we build on earlier skills to provide you the opportunity to enhance your later skills in this degree course. So in the early years of the degree course you do a lot of programming, and you also get some basic introduction to software engineering as well. In the third or fourth year, third year for most people, sometimes fourth or even fifth year, the software engineering courses that you have a chance to do are this one, where we focus on software design, and also the software testing course, which is a very good pairing of courses if you are interested in going on to do software engineering seriously, although people can also do just one or just the other. And then next year we have a course whose title may vary, but is something about process and architecture, so that's, if you like, it's the even more high-level stuff that builds on top of the design and testing skills that hopefully you develop this year. So in this course we assume that you can program in Java if we give you a design. Okay, so you can't necessarily develop a good design for yourself yet, although some of you will have more experience with that than others. But the idea is that after this course, provided that you understand some requirements, you will be in a position to develop a good object-oriented design that will satisfy those requirements. And if you also do the software testing course, then you'll also be in a good position to test whether the code that implements that design is really doing what it's supposed to do. And if you go on and do software architecture, process and management next year, then you'll understand a lot more about how all this stuff fits into organisations, although we'll talk a little bit about some of that as it pertains to design and modelling this year as well. So the elephant trap that we have to try to avoid, and so I want to talk about it right now, is this. When you are a university student, and actually to a large extent when you are somebody working in an internship or in a summer job, you tend to see small software systems and you tend to work with them over quite short time frames. And so you tend to be in a situation where it's possible for you to have a pretty good understanding of the whole of a software system. And in that kind of context, you may well feel, with some justification, that you don't really need very much in the way of sophisticated understanding of design or modelling. It works all right to do a reasonably thoughtful job of programming, but basically to follow your nose and do something that we might pejoratively call hacking. This does not work at scale. And there is a lot of software at scale out there, and if you become software engineers you'll spend most of your lives working with software at scale, where you absolutely will need an understanding of the kind of techniques that we're going to discuss this year. So I'm going to try to help you to understand why the techniques we learn are actually worthwhile, but it will require a certain amount of suspension of disbelief on your part, because if you just evaluate them against your short and small experiences, you may just not get it. So the crucial thing for you to remember, if you are not so fortunate as to have experienced it directly so far, is that real-world software systems can be many millions of lines of code and can be many hundreds or sometimes even thousands of person-years of effort. They can be spread over many years. They can really be extremely complex. And managing that complexity is a large part of what software engineering is all about, because with most of today's systems it is absolutely impossible for any one person, no matter how clever and how professional, to get their head around all the detail. And so we have to have techniques that will help you do that and make sensible decisions, even though you have to be abstracting away most of the information about the system. And that's a very interesting problem, and that's why design and modelling are interesting things to study. learning to design well, it's hard, actually. We talk about software design, and of course it's not quite the same kind of design as you might do if you were designing, a world-beating teapot, but it's got some things in common with it. I sometimes have a quotation about balancing constraints, and the idea that there is no one ideal solution to a design problem. And I'll probably stick it on a slide later on because it's a nice quote, but I can't actually quite remember enough to tell you about it right now. Teaching somebody to design well is kind of impossible. I mean, I cannot give you an algorithm and say if you do this your designs will all be good, because software design is a wicked problem. You always are trying to juggle too much information, and what constitutes the right design in a given setting depends on much more information than I can ever give you in a design case study within a course. And I'm not an expert software designer. I know something about what software design is, but I'm not somebody who has spent my entire career doing software design, because I'm an academic. I've spent my entire career being an academic, well, apart from a few years when I was a software developer early on. What we can teach, however, is the vocabulary of design criteria. So we can talk about what makes a design good, what is it to be a good software design, and that of course will help you to recognise good design when you see it, and hopefully also recognise flaws in software design so as to fix them when you see them as well. We can talk about how to model designs so that they can be discussed, and we'll see that that's one of the major reasons why we want to do software modelling. We want to have an artifact that actually enables discussion of things like design and which of two possible designs will be better in a given setting. And we'll also talk quite a bit about how to go about learning from others' knowledge. So I've said that I myself am not a serious expert in software design, but neither are most of you, and one of the things that we want to find out is, well, how do we go about learning from the accumulated knowledge of people who are expert software designers, and one of the ways in which we can do that is to use design patterns, and we'll talk about those too. A couple of recommended books. The one on the left is my book, which I shamelessly recommend. You can get second-hand copies of it for about 99p. I think you'll also find that there's an electronic copy available to you in the university library with unlimited use, so either of those mechanisms are absolutely fine. You should please make sure that you're looking at the second edition, because there were major changes in the language UML between UML version 1 and UML version 2, and in this course we talk about UML version 2, so you'd find it a bit confusing if you used an earlier edition of the book that is written in terms of UML 1. The other book which I particularly recommend is this one, Object-Oriented Software Engineering by Lethbridge and Lagunière. Indeed, in a week or two's time I shall be using some of the slides that go with that book. There are many other books about object-oriented software design out there, and I encourage you to have a browse around and use whatever you find useful as well. Neither of these books is remotely essential. You can get by perfectly well without either of them, but if you're looking for a book, those are the ones I suggest you look at first. I tend at the beginning of course to tell you how to be a bit mercenary and how to get good marks, and in the year-specific introduction I certainly told you about how this course is assessed. But what I'm really interested in is trying to help you become good software designers, and how you do that's a bit different from how you get a first-class mark in this course, although ideally of course I'd like you to do both. So just as people say that 80% of success is showing up, I think actually 80% of becoming a good software designer is caring and thinking about software design. And so in some ways the most important thing you can do as a result of this course is just to establish the habit that every time you read or write code, or you look at any artifact relating to a software design, you ask yourself, first of all, why is it designed this way? Why did someone decide to make it be this way? And then the next question you ask yourself is, could it be improved? And if so, how? And those questions won't be easy to answer, and sometimes you'll find yourself in a rather Chesterton's fence sort of situation, which is to say something will appear to be too complicated, and you should be quite cautious about that, because it might be that it really is too complicated and should be simplified, and sometimes it will be that there's a good reason for the complication that just isn't completely obvious to you. So you should try to understand why a thing is designed the way it is before you decide that it's wrong. So that's why I put the questions in that order. But if you establish those habits, you will quite quickly start to understand a lot more about software design and what makes a good software design, and that's how you will improve your own software design skills and have fun doing it. So what are you supposed to know already? I already mentioned that you're supposed to know how to program competently in Java, okay? And this, of course, includes understanding the basic object-oriented concepts that we can use in contexts other than Java. So I expect you to be thoroughly familiar with concepts like, class and object and method and attribute, and to have some understanding of things like encapsulation and abstraction and so on. And I also, the other strand, is I expect you to understand something about what software engineering involves, which for most of you will have got in Inf 2. So I expect you to understand the basic activities that go to form any of the various different software life cycles that might come up. So you should know what it means to manage requirements, and what design is, and what coding is, and what testing is, and so on. And you should, if you've done our standard courses here, at this point have some basic understanding of UML, class, sequence and use case diagrams. If for some reason you don't have that, that's relatively easy to fill in. The most crucial thing here is your understanding of object-oriented programming. Right, what you should do next, please, is to visit the Course Learn site, join the Piazza class, and do the reading and video watching that refreshes those prerequisites, just to check that you've got everything you should have.